NFT.
Yeah, let me just share my screen here. Can everyone see my slide here? I'm going to leave it in this mode because I jump around a lot depending on questions, and feel free to stop me. But typically, I've worked with a wide range of customers, right? Some have data scientists, some don't have any, some are in various different stages of implementing EAM. So it's hard to have a generic presentation. And some of the challenges I've had at IFS is because we're a little bit behind the timeline in our APM strategy. Lots of other competitors have much more in-depth APM capabilities, have implemented APM at customers. So we're a little bit behind as far as the market. And so the approach I've taken is more in terms of kind of like a trusted advisor, helping them understand the process to get to a predictive process versus saying, all right, you're ready tomorrow, let's implement APM. So I kind of use that strategy to set the stage of, you know what, when you're ready to do APM, we've got a great strategy and we'll help you get there. But here's the things you need to have in place to implement that type of thing. And of course, if they've got good data, right, there's no reason they can't use some of our predictive capabilities to do anomaly detection. But if they want a full strategy of enterprise-wide predictive, then they have to have some pieces in place. So that's kind of the journey I take them on and discuss those types of things. And some customers have pieces in place. Lots of them don't have a lot of the pieces, but we come to an agreement with where they are today and what needs to be in place and how we're going to get to them. So I usually start out in helping them understand what the issue is, right? So most of their assets today have random failure patterns. So even though they implement PMs and repair strategies, there's always going to be random failures, and we see that all the time, right? On the West Coast, there's fires based on bad maintenance strategies, failures of asset equipment, and we see that across the board, no matter what type of industry we're talking about. I focus usually on energy and utilities, but the same concepts apply to just about anything. So even though they're random patterns, what we find is that based on our understanding of assets, they typically do have patterns, right? So what we focus on is understanding what those patterns are for the related type of assets, and then use that information to understand the risk of the asset failing. So many times we focus on when something's going to fail, but really what's most important in asset performance management is understanding the risk associated with the asset, and then applying long and medium-term strategies on how to affect that risk. So if I need to put a budget in place for next year or the year after or 5 years down the line, if I have a better understanding of my fleet of assets, where the risk is, I can use this types of technology to develop those patterns and apply my risk budgeting based on that. And I'll get into what goes into that and understanding the risk. But the first thing is understanding the failure patterns. And I think we all agree on this. Depending on based on different types of equipment, they've got different Weeble curves and failure patterns. So one of these I thought was interesting. Let me take a look. Oh, so D, right? So you wouldn't really expect after something's repaired, right? It should perform, pretty good, like a new asset class. But many times something like, if you change a part, it's more likely to fail versus before the part was actually changed. So understanding not only its age, but the PMs and the actions taken on those assets also gives us a lot of insight to what those patterns are. So part of APM is implementing these type of patterns and the risk associated with what's happened, as well as the age of the asset. In terms of the process, and this is kind of the journey I talked about, right? Customers have some reactive type of processes, so they let things fail. They're low value in the value chain. Things like in energy, like a distribution transformer that's on a pole, right? And they're not going to go and have a standard process of replacing them unless it's a high value or high critical type of customers. But if you're like feeding 2 or 3 different residences, you're just going to let it fail. When it fails, send out a crew to replace it when it does fail. So many customers, even the higher technology type of customers, they'll always have some reactive replacement strategies. Moving down the line, preventative, that's why we're implementing EAM solutions like IFS, is that they want to have a scheduled process of making these replacements and repairing parts and refurbishing them. So they implement that. It's just like changing the oil every 5,000 miles in a car, right? Then the next process in the stage is more of a condition-based monitoring. That's what we use, IoT type of data feeding into the system and using more of a data-driven approach to changing parts, and instead of these 5,000 miles or every 6 months type of thing, you change it every 5,000 miles. So I actually, that was wrong there. That should have been a timeline, but you get the idea. And then moving down the line, predictive and prescriptive. But what I typically do, and I'm just going to go into slide mode here, is build this out for the customer. Let me just change my setting here. Let's talk about what they need to have in place. And this is really where more of the consultative approach to understanding what their environment is like today, what tools they have, what expertise they have, and then how we're going to help them get to the next step of doing APM as they move down this line. So things that we like to talk about is one is when you move from a preventative to a condition-based monitoring is IoT, right? So we've got a great solution for collecting data from various different IoT devices. So we're not an IoT platform, but we can tie in with lots of different capabilities to extract that information and ingest it into IFS for the condition-based monitoring type of capabilities. So customers do have, typically have machines and a strategy for extracting information, but what they don't typically do is give a lot of thought into what the raw data means, right? So in terms of KPIs associated with IoT, it's not so much of the raw data, but what the data means in terms of their environment. So for example, I worked with ASO for a while now, and they want to implement operational efficiency to have better understanding of the efficiency of their factories. So they got the machine shut down, but they don't really capture information on why it's being shut down. So they don't know if it's a changeover on what they're producing. They don't know if it's a downtime because of a repair that's going on. So they need to understand what the data means, but also put it into context and KPIs around what's going on. And we see that a lot, right? It's raw data. Data's dirty. It doesn't really put a lot of process around the data. They need to understand what the data means in their environment and start understanding the metrics around that. So in terms of electrical equipment, top oil temperature, right? The heating of the equipment is very important, but they need to also put that in context. What's the seasonality? So in terms of the summer, equipment runs a lot hotter than it does in the winter because of usage. So they need to put contextualization around that, and usually work with the engineers to understand what that contextualization is. Criticality is also important. We talked about the risk, but how critical is that asset? So if there is failover associated with something, it's less critical if that piece fails because it can rely on something else. What type of customer does it feed? So in terms of transformers, is it feeding a few houses? Is it feeding a hospital? So that information is very relevant to how something is maintained and ultimately the risk associated with if it fails. So we talked about data contextualization, understanding what it means within the organization, what's the historical data in terms of that, what are the acceptable values, as well as what it means as far as the KPIs of that particular asset. Data fabrics have been an important concept. I talked with Exelon a few weeks ago, and they've got 60 different pieces of different silos of data that are relevant to understanding the performance of an asset. So even though we don't really, talk about this piece of it, but it's really important to help customers understand what does that data fabric look like? How are we going to ingest all this information? Does it come into our analytics data store, or should they start thinking about their own data lake? So even though that's not really our, responsibility, we do need to help them understand what are best practices, what they should start thinking about, what are the different data sources, how should they extract that information, how does it need to be updated to feed the analytics that we're going to be implementing in our anomaly detection. So it's really helpful for them to understand what's involved with that to get them to be more of a predictive environment. So anomaly detection we talked about.
Can I interrupt, Andrew?
Yeah,
On what
absolutely,
you
absolutely.
said before. Do you see, like, on the PLC side, or Siemens, Honeywell, and those guys, that the contextualization or reason for stops, etc., are sort of captured more automatically nowadays, or that they let sort of manually label those in a much more easy manner than before?
Yeah, a lot of times it's like after the fact, the next day, the next week, where someone actually sees when it's gone
Mm,
down, and they
mm,
will annotate it manually, but that's error prone. Sometimes they forget to do it. The next step typically is they're putting like iPads at the device, at the
yeah.
machine, where when it comes down before they restart it, they can put it in, and others can actually program some of that stuff. So there are techniques they can do to start capturing that information in a more accurate and a more speed manner, but they're not all there yet. A lot of it is after the fact in a manual type of process, and hopefully they've done it right, or they just haven't put, or they just put miscellaneous in.
Mm,
Um, so yeah, so best practices, there should be some kind of automated way of capturing that and storing it with the data.
yeah. Thanks.
Yeah, no problem. Thanks for the question. And then lastly, reliability centered maintenance. So once we start moving to the condition-based monitoring and hopefully to predictive, if we can understand the failure modes and how we respond to that, that's going to help us move to the prescriptive piece. And that's what, that's all that information is typically captured in IFS as far as faults. So if something fails, we can start capturing why it fails in the system. So it's really important for them to understand what are the failure modes for assets, but also how to resolve that. What is the maintenance strategy to do that? And then we can use that information to fine tune the maintenance increments, right? So if something's being oil's being changed every 6 months, and we know something's failing because it's not being changed enough, we can we can use that information to resolve the maintenance cycle based on that. So these are different pieces they can start thinking about, and we can help them get to that based on some of the capabilities or recommendations we can make within IFS.
The question on that, Andrew.
Yeah.
How do we store that data in IFS? Do we have the capability to store that well?
Yeah, actually, I'll go into some of these things that we do support within the product after I go through this. So good question. So we integrate with third-party products. I know one of them we had talked to in the past, right? British Airways, who had an RCM product. So we can, if they've got tools that do that, we can ingest that information in, but we can also just have an engineer use our tools to define what the failure modes are and the effects and so forth. So we have the ability of defining that, not in terms of the engineer of optimizing it, but if they know what that is, they can enter that within IFS.
Cool. Yeah, no, look forward to seeing that later. Great.
Yeah, great. Some of the other things to move to predictive, failure histories, right? Supervised versus unsupervised. So starting to capture information, starting to cleanse the information. We talk a lot about the maintenance, the anomaly detections and so forth, but a big process in doing this type of thing is cleaning the information, understanding the information, the transformation of the data. So even though I don't know what the thoughts are as far as the strategies of doing that piece of it, but that's going to be an important part as far as either the whoever implements the solution of having a piece put in place to start looking at what's going on with the data. Are there outliers, extreme values? How do you respond to those? That type of information, how do you filter it out? So 80% of this task of moving to predictive is actually understanding the data, cleansing the information, and just getting more insights to what the data is before you feed into a model and you have bad results, right? You need to have good data. So we need to start making recommendations on what that process looks like, what type of expertise they need to start cleansing the information, but also capturing the data, right? We talked about the IoT and the KPIs. They need to start creating that history if they want to start eventually using machine-based learning and supervised analysis. Survivability analysis, we talked about the Weibull curve, the survivability curve, so understanding when things have failed, when they were put in service, right? IFS, we capture the in-service date, when things were taken out of service. So all that data that's being captured is relevant to doing that type of analysis. And we'll get into some of this as well in the demonstration. Asset investment planning. So even though we're not doing that piece of it yet, by doing the asset health piece, that is basically what feeds asset investment planning. So if we can be successful with the APM piece and understanding the risk associated with the asset, that's going to drive everything we do in asset investment planning, or what the customer can do with asset investment planning. So I want to talk about how customers, or what is it, methodology look like for asset performance management, but also the models that might be behind this. So this is the more traditional way of doing asset performance management. So typically there's different types of calculations that feed each step of this, and we'll talk about that. But typically the output from one feeds the input of another piece of the strategy. So this is a typical methodology associated with APM that's implemented with maybe a power company or a power plant and so forth. So in terms of the calculations, we talked about how there's a health calculation, there's a degradation model, as well as criticality information. So the information that feeds the health piece of this is typically, an engineer sits down, he understands the data that's being captured based on an asset, then do this calculation in terms of a distribution transformer or a substation transformer. They look at several different variables, things like the gas analysis. Is there any kind of physical damage to the device? Each of these different pieces of information is scored in their spreadsheets, for example, based on how important they think it is to understanding the health of it. And it's aggregated together with the individual pieces to come up with an overall health calculation. And I'll give you an example of that in the next slide. But it's typically a manual process where an engineer goes and gets lots of information based on their understanding of how an asset performs and the data that's feeding it, and they come up with this calculation, and that basically defines the health of it. And they use that. They come up with it, once a month, every 6 months, once a year. So it's a process that's laborious. It has lots of different data. They either manually have to enter into their systems, capture from third-party reporting tools, or part of their enterprise data. But it all feeds this calculation and comes up with the insights associated with the health. So based on that output, and it's typically a score from 0 to 100, and it might be like 80% health score, they calculate the effective age. So that's another calculation, depending on the type of asset, and that can either be very well known as far as how to come up with the calculation, either through industry standards or IEEE, or just kind of a best guess understanding. And effective age basically looks at a piece of asset and says, well, if it's 5 years old, because its health is degrading in a certain way, it's actually acting like a much older asset. So instead of 5 years old, it actually looks more like a 20-year-old asset because it's aging so quickly, depending on those health factors that we just talked about. And that gives it the effective age. So instead of just coming up with a degradation curve, the failure curve based on what I know about the asset, and say, well, it's 5 years old, so here's where it is in its lifespan, I want to use the effective age to give me a more accurate understanding of where it is in that failure curve. And I'll also give you an example of that as well. But that effective age feeds how it maps to the degradation curve. So if the probability of failure was 10% at 5 years because it acts like a 20-year-old asset, it's really actually a 50% chance of failure. And we use that to better understand, where it is in that curve. And that feeds me my failure probability calculation. So the criticality we talked about earlier, how critical it is, and that's kind of a subjective thing. Within IFS, we can define, in numeric terms, like 1 to 5, how critical it is, or whatever the span is. But it can actually be much more sophisticated as far as the customer's requirement. It might be critical based on, again, failover, redundancy. It can be not just to the network. So criticality can be how many customers it serves. It might be more of a financial thing. Energy has SAIDI scores and safety scores, for example. It could feed into that. It could be an environmental criticality. So lots of things could go into that. But at the most basic level, it can be just a number from 1 to 5. And we use that to understand the risk. So the risk calculation is basically failure times criticality, or probability of failure times criticality. It gives me the overall risk. And then I can use that to prioritize the maintenance strategy associated with the asset. So that when we talk about methodologies, this is kind of what we mean with understanding each of the individual pieces, the relationship of the pieces, and how it goes together to come up with the overall risk profile of an asset. Does that make sense? It'll make more sense once I get into some of the examples associated with this. Okay.
And just
Yeah,
a
I mean,
comment or input from my end as well. I'm just thinking
absolutely.
also around that data that you capture, or you decide on what level in the basically object hierarchy or structure as well, where you want to go here. Maybe the reliability curves, for example, are more applicable to components you replace from time to time, whereas you have other type of equipment that will survive, 30, 40 years, and you want to know how old they are, as you say, in terms of real values, but you don't have the data for a lot of replacements before or something like that, or failures even. So,
well, that's good.
yeah.
It's a good point. If you're saying that I don't have any failure history, so how do I come up with those insights?
Mm,
So typically what we do is either work with the vendor, whoever manufactured, to
mm,
understand their estimate of failures associated with the asset. It can be industry standards, it can be other customers that we've worked with, or consulting companies that have worked with that type of asset class before. So if you don't know the specifics based on who manufactured it, what the lifespan is, and when we talk about utilities, their assets last a very long time. Like
yeah,
circuit breakers can be 60 years old. Excuse me, poles last 50 or 60 years old, depending on where they are and the type of wood that's used. So many times we have to either estimate, use best practices, use data we use from other customers, or industry insights based on that. But it's not odd that customers don't have failure information, especially in utilities, because they replace the assets way before they typically fail, at least the ones that are high value, right?
So with
absolutely.
regards to that, replacing the assets, I mean, you were talking about the estimated age of the equipment based upon condition. So do we normally approach the value of that equipment from that estimated age and versus the value of replacing it? So look at it from a cost perspective, is it going to be, at what point do we cross over from it'd be cheaper to replace this piece of equipment than continue to maintain it?
Yeah, it's a great question. That's usually part of the asset investment planning strategy. So if you come up with a list of, so typically what a customer would do is specify a project, right? So my engineer would say, all right, I need to have a project as far as understanding what circuit breakers I'm going to replace. And they'll go in and understand the health of those circuit breakers to come up with a list. Once they have that list, they're going to go in and either, well, maybe not replace, but let's just say the refurbishment of circuit breakers. Come up with a project and come up with a list of what needs to be refurbished, either based on how old it is, how critical it is, and so forth. And based on that refurbishment list, they'll take the next step is understanding is, well, how likely it is to fail. If it's going to fail next year, there's no reason why I need to refurbish it, right? So that is part of the investment plan, is understanding each of those different pieces, where it is in its lifespan, what its refurbishment strategy is, what are the maintenance strategies based on that, and then kind of normalize it based on the results of this analysis. Is that what you're asking? Kind of.
Yeah.
Yeah. Yeah. So by having these insights based on these different models, I can take it to the next step and do that investment planning, and then take each of these different things out. And based on that project, I take circuit breakers out or add new ones in based on the insights that we're coming up with this analysis.
And hi, it's Simon. So we currently have a feature in development for 23R1 to be able to structure recording asset conditions. And we've put in pretty much exactly this with a score and a weighting as well. What I'll do, so I can't remember everybody's names that are involved in that team, but I'll write in the chat, and if we can share this recording with them as well, they can validate that the condition recording part that we're doing is fitting with this.
Okay, great. Perfect. So in terms of the asset health score, we talked about this in the first box of methodology, is how does an engineer today come up with the health score? So this is an example of a transformer, a substation transformer, and the types of data an engineer would capture, and then how they would score it in the system. So for example, the pushing condition, right? So some of these are, you actually go to IFS, EM, for example, and someone's gone out to the field and done an inspection, and they've captured this information in IFS, right? So is there anything leaking, right? And some of the customers, part of the best practice is to understand what these components are and add that to the process of doing inspection. So if they're not capturing oil leaks today, well, that's something they should start doing when they do their PMs, right? So helping them understand not only, what are best practices, working with their engineers to understand what is the pieces of information that are relevant is part of the process of helping them define what is done during the PMs, right? So some of this is inspection information, some of it's information they send out to a lab, some of it's sensor information. In some of the older transformers, the oil analysis, like DGA oil analysis, basically they go to these transformers, they extract a little oil, they send that to a lab, and they look at the components within the oil, right? So that's done typically every 3 months, every 6 months. Newer transformers have sensors within the transformer. They can do this, several times a day, every 15 minutes, for example. They'll sample the oil, and it's kind of like taking a sample from your car and analyzing what's in the oil. Where in a car you're looking for like metals and so forth. In a transformer, basically the windings give off gas as they heat up, as they age. It starts gassing into the oil, so they're looking for things like hydrogen and nitrogen. So what are the components of the gases within the oil? That gives them insight to what's going on with that transformer. So each of these different pieces, the engineers say, well, I know the DGA is the most important thing to understanding the health of a transformer, so that's a priority 4. Other things like oil leaks, that's not as important to understanding the health of an asset, but I still need to capture that. So that's less of an importance. So I basically define what the ratings are in terms of the weighting and assign that to each of these different things. Each of these different measurements is given a condition rating. Here I've done A to E, A being the healthiest, E being the least healthy, but it could have been 1 to 100. Everyone's does this a little bit different. It can be 0 to 5. But for this example, I've just done A to E. Some of them have just 2 ratings. For bushing, it's either healthy or not healthy. So the engineers can basically say, based on his knowledge, either by industry standards or how they'd like to do it, they basically define a rating, and based on their insights of this, either an actual score or an interpretation, they assign it one of these. And then that gets converted to a number, and they multiply that number based on the score by its weighting. And then we sum that up over the total number or the maximum rating. That gives us the overall health times 100. So this is kind of the traditional way. It's very labor intensive as far as gathering the information. Labor intensive based on how often you can do it as far as getting updates. It may, because it's so labor intensive, they may only do this once a year. So there's lots of room for improvement if we can start doing IoT type analysis or anomaly detection, right? So if we see a lot of anomalies in the DGA, well, that can start overriding a lot of this. And typically when customers implement this, even the traditional way, there's lots of overriding that takes place. So if I see my double test from the last one has a significant change, so I've gone from a B to a D, well, that's going to be a red flag to me, and I'm going to override some of these other things to give this a bigger rating. So there's lots of overriding that takes place. So that's kind of like the contextualization of the data, is because I see big changes going on in something, I'm going to start magnifying that and overriding some of the other things. But IoT and predictive can, a lot of these things can start overriding what customers are doing today by using that level of data and the machine learning to create a more automated method of responding to these different things. In terms of the interpretive things, just to give you some background, so what does like an oil leak mean? How do I interpret something that's going on? Is it a lot of oil or a little oil? What does that mean as far as the rating? Many times there's industry standards, or the customer may have their own best business practices. So for example, if I look at my insulators, how do I define A to E based on what I'm seeing, right? So they may have a set of standards to look at that information and then associate what they see. But again, this is kind of interpretive, it's subjective. It could be error prone, but this is typically how they do things today. But again, another great way of using machine learning is to start just taking information they're doing, maybe text-based analytics of mining this information and coming up with these insights. So there's lots of ways of improving this based on technology, right? So does that make sense? They just look at the log information, the data that's captured by the field based on what they're saying. They assign that to a score or letter that transfers to a. Yep, great, and that's how they do it.
Andrew, one question. You mentioned that machine learning and sensor data can override some of this way of scoring. Are you going to explain that?
Yeah, let me give you my example later
Okay.
and see if that answers your question. I think it will answer. So you're saying how can you use machine learning to override some of these things?
Yeah, because basically this is the more manual process, the traditional way that you explain. And what if we have streaming data from sensors? So how do I incorporate that into my scoring?
Yeah, well, so let's take a look at that. Well, in the case of a circuit breaker, time travel, how long does it take to open and close a circuit breaker? That's all data related, right? So it's microseconds. And as a circuit breaker ages, it may take longer to actually trip the circuit. So we're using data, right, to do that. It could be a manual process. Maybe someone needs to go out and test a circuit breaker to find out what the open and close time is. But if there's a sensor, right, capturing that information every time it trips, that's a piece of information from IoT. We're going to automate that, right? So a lot of times, some of these where there's data associated with that, someone's going out and testing it. The resistance, someone goes out and tests the resistance of the circuit breaker. The stored energy, a lot of these are just someone's going out every month and testing these circuit breakers. A lot of the newer circuit breakers, they're automatically capturing this information based on sensors. So we can automate all this information from the IoT data we're extracting from that sensor, putting the rules around this, and then updating the health every time a new piece of information comes in. So a lot of it depends on the asset, whether it has sensors associated with it, if there are sensors available, can they be retrofitted, but understanding what that data means and how it affects the health is probably more important than just the raw data. But some of it's
Andrew,
yeah, go ahead.
So I have a question about so the description, is it a free text that the technician is feeding?
Yeah, it could be. Many times what we would recommend when they implement this, like in EAM, is to have drop downs, right? So instead of typing something in, they're going to select 1 through 5. And these are pre-populated, so they read it and they say, all right, it's B, right? So we probably want to move away from free-form text because it's hard to interpret. There's, everyone writes things differently. It's full of spelling errors. So best practices is helping them understand what the description should be, but putting those as options or drop downs when they're capturing that information versus having to type it in with gloves on, for example.
And in practice, how this is actually being adopted? I mean, does the technician actually populate things in the field? They're not making like null values, because I come from the field service management, and some of the data are actually missing because technicians are actually, I don't want to say lazy, but if fields are not mandatory, so they're actually skipping those things. So how the manager in the asset, actually encourage the technician to actually populate data inside of it?
Yeah,
because this is not this is not IoT data, right? This is
Yeah, exactly. So typically, what some customers would do is kind of reward field people. So the more accurate information is, they get scored themselves and might get bonused or whatever.
So using gamification for that.
Yeah, it's more it's educational, but also reward based on how well they're doing, how much information they're capturing. But you're right. A lot of times we look at this information, it's just miscellaneous or it's just missing. But if it's a mandatory field, they need to put something in. But yeah, so it's a combination of education, rewarding them, and so forth to get the most.
I guess information. I guess we can only know that once we have the data, right?
Yeah, exactly. But again, that's yep. Go ahead.
And the process here, I'm thinking, are they adding the condition rating when they close their basically work order, or do they have to go in and set that up or change that for the asset health?
So as far as capturing these pieces up above here, when is it done?
Yeah, I'm thinking after you're done with your work, for example, is that when you captured it, or when you have taken a measure or something like that? where you
Typically,
add the
yes.
condition rating.
That's what we would, hopefully they do. So when they're doing
Yeah, so they don't have to
PM
go into another, let's say, page or module on the asset health side to change that. It should be fed automatically on where in the process they are working in today, right?
Yeah,
Correct. So
sorry.
if it's like a mobile device, or if they're on the mobile, IFS mobile, we can just add these pieces to their process, right, to capture this information.
Yeah, sorry, I had to leave the screen for a while looking after the kids. So pretty much exactly that. The design for taking conditions will be like taking our measurements or counters right now, which you can do in the back end client, but we'll also be able to do it in mobile. It will have a different screen called conditions for object, but it will look pretty much the same as measurements for object, which we already have. Apart from the answers won't be a temperature or a counter or a number of hours run or whatever. It'll be A, B, C, D, or E, which will be configured for that object type. So the questions would already be configured for the object on creation.
Good.
Great, good questions. Let's see here. I wanted to talk about data a little bit in terms of contextualization of the information. So lots of customers just think, we've got lots of data. I can just feed that into your system or feed it into a predictive model and it's going to come up with insight. Well, it's never that easy, right? It's taking raw data, but also creating metrics around it that we talked about, but also aggregating it at a higher level. So if we're taking in second by second information, how does that get aggregated up? But ultimately, what we want to do is create observations, not only with the raw data, but also with exogenous information that might put it into context. So that can be history. In this case, if it's a turbine, it might be weather-related information. But customers need to understand it's not just the raw data we're working with, but we're putting that into, normalizing it. If sensors are reading different types of data, so might have Fahrenheit for one sensor, it might be Celsius for a different sensor. The first thing we need to do is create a normalization across all those different data types. So they need to understand where the data is coming from, what can be added to the data to put it into context, but also how it should get aggregated, what metrics are associated with the data. So not so much the raw data, but what does it mean in terms of the asset? So for example, the temperature of the windings of a transformer are important, but really it's really more important to understand what the top temperature was based on the season, for example, or how it's being used. So many times it's not just the raw data. Many times that's it's not really useful. What's really more useful in understanding the health of an asset is how it's affecting the asset. So those metrics, those KPIs associated with that. So it's not just downtime, but what type of downtime is it? And then what's the history associated with that? What are the upper and lower bounds associated with those values in terms of that asset? How often has it exceeded those bounds? So when you talk about, a lot of customers, they talk about, we need to work with your engineers to understand how this takes place, not really in a silo. And what's happened in the past in this area is predictive has been oversold, right? If you look at GE Predicts or IBM Health, they were saying, all right, tomorrow you're ready to start doing predictive. And it's failed for a lot of reasons because they didn't have those building blocks in place, but they also didn't have insights to the data and how it affected an asset, right? So they try to go right to the last step, not applying any of the insights and the engineering associated with something and just taking raw data, and it really was meaningless. It needs to be put into context. In terms of that asset, there needs to be external information that puts it into context, like weather information, but it also needs to be done as far as metrics. So in terms of health, someone's health, right? It's not their height and weight, it's the body mass index. So we need to basically work with customers to understand what those metrics are. And that's the data that's captured. And those are the observations that are typically fed to machine learning. And so how we do this is, I guess we have an analytics data store, but is that the best area to do this? Is there external information or analysis that the customer is going to take advantage of outside of IFS? So a data lake might be more appropriate to do this type of analysis, but there's lots of different choices. So I think in terms of working with customers, they need to understand what are the options, what are the limitations doing it all within IFS, or what are some of the other vendors they should be looking at. But we certainly need to be able to come up with a reference architecture based on different situations, the amount of data, the types of data that might be feeding their analysis. So there should be different ways of implementing this based on those requirements. So we talked about the methodology here, the degradation curve, right? So the different types of distributions, normal versus the Weibull distribution. Again, you're going to need to know either way what the failure processes are. But again, we want to be able to generate this based on either the customer's data, industry data, or the manufacturers of the equipment's data. And that's not so much your job, but it's really more the implementer or the consultant that they're working with to come up with those insights and working with their engineers. But ultimately, this is what gets fed into the system. I think that was it as far as slides. Any questions on this so far? Okay, we can always come back to that as well. So what I typically show customers is a few different things. Let's see if may have timed out here. But the first thing I like to do is take them through my example dashboards for a transformer. So these are my made up APM dashboards. I built these using Power BI, and the data is just make believe, but it's typical of the types of views a engineer might want to go in to understand an asset class, his fleet of assets at the aggregate level, but also drill into the detail associated with that asset to understand its health, and then potentially how to either fine tune the maintenance strategy, or like we talked about earlier, what that investment plan might look like over a period of years. Do I replace something if it's about to fail versus doing an expensive PM if it's about to fail as well. So these insights allow the engineer to do a lot of fine tuning as far as the PMs, the investment planning. If it's a longer term plan, 5 years out, well, what does my budget look like based on the risk associated with my assets? So APM feeds a lot of the different insights an engineer might be responsible for based on that asset class. So in this case, let's say they've got like 20 substation transformers, and these are the big boxes you see on the street that take, a transmission line, high voltage, and bring it down to more of a residential, lower voltage distribution. So in this case, I basically defined what the what those inputs were based on the health, the risk, and criticality across all those different assets. I've got the scores over here. I've got a risk matrix. I can drill into this different ways based on what I want to highlight in the system. If I see one that's at high risk, I can just click on that and drill into it. But this gives an engineer a view of overall risk. I can compare risk from different divisions. So maybe I've got an East Coast and a West Coast location, so I can break it down based on different geographical locations or different areas within the hierarchy of the organization. The idea is I want to better understand the risk associated with that, focus on those assets that are highest risk and understand what's contributing to the risk, but also what to do about that. So in this case, I can see I want to, I've got a high risk transformer here. It's got an E score, E risk, its service age, so it's 12 years old, but its effective age is 63. So something's going on with this transformer that's making it age a lot faster based on those components associated with its health. And we'll get into that as I drill through this. But just an example, this is what customers typically say. They want to sit down at a dashboard, understand the risk across all their asset classes, and then drill down to understand what's affecting that, automate the process of generating work orders or PMs based on the insights that's coming up from the asset health as well. So this gives me that insight based on all those KPIs that we talked about. So the next thing I'd like to do,
Andrew, sorry, just from that insight then. So this is a great sort of summary of where we are. How do you say you generate the work order from here?
Well, there's a few things. One, I'm going to give you some examples of that next, but it could be just as the asset health decreases over a certain threshold. So once my asset health is below 30%, for example, automatically do an investigation. So it can be just a threshold based on the health that's going to generate the work order. Okay. I'd like to actually take it to the next level is based on what's going on is make the recommendation, the more the prescriptive piece. But it could be as simple as, once the score exceeds or goes beneath a certain level, either by its health or its risk, to generate the work order, right? Or the investigation to determine what's going on with this.
One more question, Andrew. Is this more a reactive piece? Because what about predictions? Are we incorporating those in the asset health?
So yeah, so probability of failure is a prediction. The asset health, that really depends on us, right? So what can we use predictive models for versus what are the conditional type things? So if we go back to this information, right? So the health, these are some of the components, whether they come from someone just entering the data or from IoT. It's really, up to us to understand where the data is coming from. If it's actually IoT data, well, then that's part of the predictive model, right? Are there anomalies that we're reading? Is it a supervised learning? We're looking at history of failure predictions, or history of failures to come up with that prediction. So it's up to us to plug in where predictive models can fit based on the underlying data associated with this.
Right. So for example, if one of those we have IoT data and we forecast the values, we could use that for in our index.
Yeah, absolutely. And I'm going to give you an example coming up here shortly. So health insights. So we talked about IoT, right? So let's say the DGA is coming in from IoT data, right? So here's the raw data coming in. We use our models to understand what's going on there. So we can do a predictive model based on failure information in the past based on the DGA composition, right? So that's one model that could be built, right? So today what a customer does is basically looks at the raw data. They do a calculation based on the total dissolved gases. So they calculate based on all this information, what the total dissolved gases are. They do insight based on that. They look at the changes in the data. This is called a Duval's triangle. It's a tool that engineers use to understand the migration of the gases. So over a period of time, how is it changing? And based on that, that gives us insight to what might be failing within that transformer. I can look at my winding temperature. That's another sensor of data, right? So every day I might get a new temperature reading. So I can put that into context as far as, correlate that with failures in the past. Is it heating up a lot based on, here it's August, right? So I'd expect it to be hot. But if it's heating up in February, well, that might be an anomaly, right? So that might be an anomaly feeding my health score. The oil temperature is something else. So based on the data, where it's coming from, lots of potential models that we can build to interpret this information and apply it to the health score. So these are my failure modes. These might be just information I've captured in IFS, right? Things that have failed in the system. And I'm just aggregating and counting how it's failed. But I'm going to use this information potentially to map the predictions to how to resolve this in the system. And we'll do that next. Here's my failure curve. So I've basically taken this information, do a forward-looking prediction on how it's going to increase in either its probability of failure or risk based on all these insights that we're capturing. So it's based on the trend here, right? I'm going to do a time series prediction and say, well, it's going to increase my probability of failure today, 22% to 67% in maybe 5 years, right? So that's a big increase based on the trend. So that's another model, right? If I could do a forward-looking prediction based on the trending of information, that's going to give me insight to how this is going to incrementally increase its probability of failure, and then I can take action based on that information, or I can adjust my investment plan to say, right, I never want to have more than a 30% chance of failure. That might be my threshold. Once I can make that prediction, it's going to increase that piece of that failure probability, then I can trigger a work order, I can trigger a replacement strategy, whatever the rules are, but because I can do this forward-looking prediction based on how it's trending and the data behind that, that might trigger the work order to take place or the replacement and so forth. So that's how.
So here you are looking on. So here you are looking on a single asset, right?
Yes. Now I drill down into that one asset that had the high probability of, or had the poor health rather. Okay. Then lastly, so what to do about this? And again, this is just an example. So I've taken all my failure modes in the system. So bushing failures, I had a insulation failure, oil contamination. So these are just things that have failed in the past. Here is the effect. So how should I resolve this based on the maintenance strategy? So typically I clean the bushings maybe every 90 days, right? So that maintenance strategy is typically to prevent a bushing failure. And what I've done is said, well, if I can predict based on the underlying data, like the health data we just talked about, all the different types of data I'm capturing, finding the correlation between that piece of data and what's typically found in the failure mode, I can come up with a better way of updating a maintenance strategy for that asset or asset class. So here I'm saying, if it's a bushing failure, one piece of information I use to understand bushing failures is an infrared inspection, right? So my predictive model, and this is just a make-believe score from 0 to 100. The higher the score, the more confident the model is that there's something going on here. It might be an anomaly score, for example. So if I'm finding, well, based on an infrared inspection, that there's some hotspots associated with the bushing, I'm going to say, all right, I'm going to automate the processing. I need to clean the bushings a lot faster because it's likely to fail, and I can't wait 52 more days to do that. So I can automate the process, saying, all right, let's go out and send someone to clean the bushings. Maybe I want to change my maintenance strategy from 90 days to 60 days because I'm seeing a lot of failures here. So by combining the failure modes, what to do about that failure mode, and the predictive models that have that know the underlying data, I can in real time or on a daily basis understand the data and then what's likely to happen, but automate the process or fine tune my maintenance strategies to eliminate these failures in the future. Does that make sense?
It does.
Where
I'm
did you
thinking
get
about
it?
how
Yeah.
you can generalize that, as
Yeah.
much as, or create a framework to generalize that, the creation of models that will allow you to do that. But I mean, in principle, I see how it works. It's quite hard.
And again, these
to
are goals. These are kind of the goal, the vision we're setting for customers. How they get there is a combination of the tools that we provide, the expertise that they have, but these are longer term goals, right? How do you get to a prescriptive way of managing your data? But you're right. I mean, this is not easy to do. They need to have all these pieces in place, right? And have an understanding of what the failure modes are. But if they have that and understand the data that's associated with that, we can start building the models around that.
And that's great. I think we just need to make sure we design our framework so that if and when they get to this stage, they can use our tools to take this next step. That's all. But
I'll defer to Martin and some of the product management people to, if that's kind of their same vision. But this is typically, what I talk to customers about and kind of the vision I help them understand. But if there's a different strategy, I'm open to discussing that as well. But this is typically what I see customers wanting to do, at least, and merging all those things together.
Sorry, I double muted. So yeah, it's very close. I've already written to the development team on the condition recordings, saying let's catch up after Unleashed. And I've put the names of the people that won't be able to see the recordings in the chat. We have that feature that I've put in the chat. We then also have the asset health index feature, which is, we're a bit vague in the feature requirements, but it's around pretty much this, rolling it up to see the health of the asset. And then recently, Bob, myself, Anna, Petya, Martin have been looking at the how we can use ML, etc., how we can become predictive, etc. And recently we've sort of come to the agreement maybe we need to get this foundations set first, but we're still working at it. So but what you're showing, Andrew, is pretty much what our design says as well.
Okay, great.
Definitely around the conditions. And I think it probably helped us a lot here as well for the asset health index.
Perfect. So as far as the capabilities within a product today that helps, get to some of these things, Let's see here. We've got failure mode that I haven't gone through here in a while, but let's take a look to see this, where I got it.
So it's worth just stating, Andrew, I put in the chat earlier, the RCM integration to BA systems has been deprecated, so we are replacing that. We're also going to enhance the Formica stuff because it does a job, but it's probably not as advanced as we've been asked for by some of our clients. So that's on the roadmap for 23R2 for the Formica and RCM replacement.
So I went into the failure modes functions. So you're saying this is not going to be available anymore?
It's going to be, so the RCM stuff, the integration to the BA system stuff is deprecated, and what you're seeing now will be changed,
Okay.
but not until October next year.
Okay, so for my demonstration purposes, typically what I do is map those failure modes that you saw in my report, and this basically just allows you to define what those failure modes are, the symptoms, and then typically you can, when you're doing a fault report, you assign it to, you know, what you think is failing within that device. So it's basically just defining what those functions are, what the fault types are, what the symptoms are, and then typically, you know, how to resolve that. And this is linked to a fault report. But again, it's pretty basic. I'm just saying what the hierarchy looks like, what the types are, and then what you might do about that, right? So if the vibration is increasing, it might be a normal wear. So it just kind of a manual process, but it lets you define what the hierarchy is. And you know, like I mentioned earlier, there was typically there were third-party products we could use in the past that we integrate with, and it populates all that information. But like Martin says, I think there's probably something that's going to be more substantial in capturing this information and linking it to your.
Yeah, I think so. We have a letter of intent with Tetra Pak and start workshops there next month to start defining the RCM piece, and then we have a couple of actions sitting inside our half for 23R2 to look at the Formica piece as well. So it's something that you can do, as you say, you can do basic stuff today, but we're looking to improve it.
Okay, great. Perfect. And again, you may have seen a lot of this stuff in the past. How we do this for test points. See if I can find this information. So when we talk about the IoT information and how we do conditional maintenance, if I go into my object navigator that shows me my hierarchy of assets, I can associate test points with those assets. So for this tapping machine, 2 of the test points of how is operating hours and number of hits. I'm assuming that means like, you know, ons and offs, for example. So we're basically linking its sensor data and linking that to a PM that could be scheduled. So this tells me there's 2 different test points associated with this asset, and then I can link it to PMs. So instead of the calendar-based schedule for some of the maintenance, I can use the condition-based maintenance. It shows me the last reading associated with that. It's telling me every 300 hours or 100 hits to execute this maintenance cycle. So I can basically link it to a calendar every 6 months or a reading from its sensor that tells me how often to do the maintenance versus the scheduled. I haven't seen that before. It's just allows me to link it to those test points and test those conditions.
And you can generate a PM plan as well according to those conditions, meaning that will automatically create when the next one is most likely to be from your statistics.
Yes, you can predict it, right? Is that what you're saying?
Yeah.
Predict. Yeah.
Not
so,
predict machine learning here, but just statistics, right? So yeah.
Yeah, it's going to hit this 300 hours next month. So
yeah,
generated. Yeah, exactly.
How do you know? How do you know if you are over maintained? Are you evaluated?
I'm sorry, say that again. What do you mean?
How do you know? I mean that you create like, okay, so here you basically create like a PMs order, right?
Yes.
how do you know that it's not calibrated enough and you actually over-maintain? You're actually creating like a tight PMs. Basically, you don't need to do any PM. You can avoid that. You can skip that. You can actually increase the gap between one PM and the other PM. So there is a way that you actually evaluate it based on, or it's like based on criteria that during the implementation it's being populated.
So that's more the asset health piece, right? The interpretation and the information you're getting from asset health. So if you go back
But
to,
is it been feeding in back to the application? It's been modified, or this is like preset of values that has been populated during the implementation, and once it's there, that's it. Or you can change it, but it's not. So there is not data that actually been calculated doing work and then feeding back and try to find like the more
the prescriptive piece. Nope, nothing that I know about today that we have. It's more of a engineer looking at the data. But I think that's kind of the goal of asset health, is understanding its condition and then fine tuning it.
So this is another use case of machine learning, if you think about it.
Right. So if you want to fine tune it, right, on an asset by asset basis, having those insight, the bearing's fine. There's no vibration, right?
Yeah.
Exactly.
Yeah, like a closed looping processing, yeah.
And Martin, I don't think we have that today, but that's kind of the strategy, right? Long term, how we can leverage APM to fine tune.
I don't think that no one has. Yeah, I don't think that no one has actually that today.
And actually, I kind of vision wise, I kind of show something like this. Is if we had our maintenance plan, we can come up with a recommended maintenance plan based on those insights, right? And this is kind of how I envision it. If every day or every month, every year, we automate the processing, making recommendations to maintenance plans based on the asset, how it's set today. So instead of instead of 29 days, you can do it in 5 days, right? So this kind of visualization, this way of looking at what's done today and coming up with recommendations based on the predictions and the sensor information is how maybe an engineer can understand the predictions, but also the recommendations on how to tune the maintenance strategy based on those insights, right?
Yeah.
So I think anything else here to talk about that was interesting.
So basically, if I understand, there is no way to avoid any man in the middle when we try to build a model to predict something, right? We need to have someone. I mean, there is no, of course, there cannot be like a generalized thing. I mean, we can develop something that can be generalized up to specific level, but still we need to have like a domain expert inside of it that need to provide his input, right? For specific asset, right? We cannot generalize one asset to other things, right?
That is kind of my what I've seen in the past is really there's no getting around that engineering expertise if you want to build good models, right? So taking the raw data and feeding into the system, it'll get you to one point, but it's really understanding the relationship of the data, the metrics associated, how it gets rolled up, what the relationship of the data with the actual functioning of the machine. I don't think there's any real way of getting past that. I know in machine learning, there's some automated ways of looking for relationships in the data to come up with that transformation.
So what companies do? I mean, they're hiring like a data scientist that's creating their own models, or they're trying to go into the third-party solution. I mean, based on your knowledge.
Yeah, so I think it's a combination, right? They need data scientists, right, to understand the models and how to apply the models, but they need the engineering expertise. So they typically work together, and it's kind of it's weird because the engineers kind of don't trust, anyone else. They want to do these things themselves. They want to own the process. They want to do it in their way, and then just give the results to the maintenance people, right? So it's kind of an ownership thing. It's hard to get around. And that's kind of really why we want to leverage the data to do this type of things. But I think we're always going to need the engineer to interpret the data.
So when Tangent comes and say we have like a generic solution, how does it fail with this assumption? I mean, They don't
Well,
say
I mean,
that.
that
Yeah.
whole train thing example they showed us, to me, means they don't really understand the data, right? And how it affects the train and the battery. So I think that's, I mean, it's great to say, well, there's relationships of the data, but how meaningful is that relationship unless you have the engineering expertise and how a battery works?
Yeah.
It's hard to see the value of it because you can
Yeah,
come up with
but
that.
I think it's a case of where the engineering value has to come in, right? And we have to be careful that we try and minimize the points where you need it. I think certainly in terms of understanding the meaningfulness of those features was very important, as you say, Andrew, because there were features in the model that didn't make sense, but the actual building of the models and all that analysis piece and taking analysis from the data once you know it's the right data, I think we can automate that, through Tangent or whatever else it is. But we are going to need engineering expertise around the side. I think we just want to try and minimize the touch points.
And I think part of it's also empowering the engineers themselves to use these tools to come up with these insights, right? So instead of saying, right, we need a data scientist to do all this stuff and then get the insights from the engineer, engineers today use tools like Prism, right? Prism's going to be building anomaly models based on the data, right? So the engineers using that. So tools that can help them and empower them to come up with these insights and then implement the maintenance strategy, I think is also another strategy versus, a segregation of duties, because I think taking them from the back office or the back room and starting to build these with maintenance people, I think there's a good strategy there of taking that expertise and letting them build the models and understanding the insights, because a lot of this is back when we looked over here, a lot of these things are, data that's hard to get or in a lot of different places that's old. If we can start building models around individual pieces here, that gives the engineer insights for some of these values and automates it. So that's valuable to them too. So if they can come up with these anomalies themselves and understand what's contributing to that, they can use those models and implement, because you don't need to be a data scientist anymore, right? It's just applying my knowledge.
Exactly. And that's very much in line with our general strategy as a company, right? And around AI, which is, we're trying to deal with the end business users and not the data scientists. And I think that fits in line with that. So we have to get the tooling right to support them, dependent on, them getting hold of all the data in the first place.
And not think about machine learning for machine learning sake either when it comes to models in general. Could be any type of model.
Yeah, I mean, it's whatever they need to
Exactly.
make better decisions, right? Whether that's machine learning or not.
Hopefully, and good use of our time.
I think it's been very helpful. Thank you. Yeah, it's been really good. I think we need to think about how these ideas and these visions map into the product roadmap. Yes, I think there are bits we've got on the roadmap, as Simon and Martin have mentioned at different points, and we're looking at various pieces or ways we can capture the data, but we still need to tie it all together. I think that early slide, I don't know if you could go back to the slide where you kind of showed the progression through 13, I think it is.
13 is the methodology.
Yeah, but I think this is helpful. Well, this certainly helped me try and kind of piece together the flow of the data and the flow of the analytics and how the different pieces lead into each other. I think, we need to try and design the framework around these flows in a generalized manner, make sure we capture the right data at each stage. But this kind of gives us a path rather than just sort of a set of independent services, I think, which is what we've got at the moment. This gives you an actual sort of journey towards completing the picture. So I found this one particularly helpful, I'd say.
Agreed.
Great.
And also by, well, an unfortunate stroke of luck, if every cloud has a silver lining, we have a phrase for. Andrew is with us next week as well, so we could spend some time, as long as we get time, to look at what's already in our planned roadmap, if you like, our planned releases for up to 23R2, and the roadmap beyond, and just see if all of the requirements are in there, what's missing, and also, Bob, highlight, where is this just normal product plus embedded Power BI, and where do we bring automation and ML in as well?
Yeah, exactly. And where do we bring the data in, right? How are we making sure that we're capturing or maximizing the chance to capture the right data at each stage, which is something that it sounded like you were considering at least some of those points, Simon. We probably need to just make sure it is the case all the way along.
Yeah. And this slide, it actually answers it in a way.
And also in terms of the solution, we also need to think about, well, I've built like 100 or 1,000 different anomaly models, right? How do I manage that? How do I update them? How do I test how well they're performing? So there's a collaboration function, like I need to work with other people to get these models out. What does that collaboration capability look like? How do I manage all these models once they're built? How do I test them? Are there competing models like champion challengers? So kind of more of a, what does the environment look like where I've got lots of things going on across lots of different data points, and how do I manage that to make sure it's effective, right?
Yeah, and I think those sort of collaborative ML ops types functions are things that we are building out anyway as part of the the machine learning 2.0. But we do need to think about how it fits into this particular context. But the idea of model management, running A/B tests to do champion challenge, all that sort of stuff is going to apply across a number of use cases, not just this, but certainly fits well in this context as well.
Good. So that's all I had. But like we said, I'm around next week. I'm around all the time. You guys have questions on any of this?
Thank you, Andrew.
Yeah,
I really
awesome.
appreciate it,
Thanks.
Andrew.
My pleasure. Thanks for your time today.
Thanks, Andrew.
Yeah,
Guys.
catch you later. Okay,
Cheers.
bye.
Bye-bye.
Cheers. Bye.